AP Chem Series. This is Mrs. Vandeloy, not bringing you another blank wall, but instead bringing you a WSQ after you have seen a blank wall video, okay? So we are in section 17.8, and the first part of the question, let me scroll down here, is, in your own words, what is the purpose of the section, and why did we need to wait until now to discuss it? So the purpose of this, well, maybe you had to go back a little bit and realize, okay, what was chapter 17 all about? I don't remember chapter 17. Chapter 17 was about, delta H, that was your enthalpy. Talked about delta S, that was your entropy. Put it all together. In section 17.7, we learned about delta G, that is the Gibbs free energy. So the Gibbs free energy was determined if a reaction was thermodynamically favorable, in other words, spontaneous or not. So if delta G was negative, it was spontaneously favorable, or spontaneous or thermodynamically favorable. If delta G was positive, it was not. But why did we stop right there? Because delta G had to be at standard conditions of 1 atmosphere at 25 degrees Celsius. So what is section 17.8 all about? Well, what if we're not at standard conditions? So, okay, why did we have to wait till now to talk about non-standard conditions? Because Q comes back. Q are the conditions that are not standard or not at equilibrium. So that if we have a Q of less than 1 or greater, whatever, we will know what to do. So we had to go from chapter 14, where we were introduced to Le Chatelier and what Q is, to now. Okay. What is R? R is the same as the last time. It's 8.314 joules per mole Kelvin. All right. So here we go. What is Q? How did we define Q? Well, Q will tell us if we are under standard conditions, Q is going to equal to 1. What if we are not at standard conditions? All right, well, then either your Q's bigger or your Q's smaller, and that's what will tell us what's going to happen. Are we going to shift left or shift right? Okay, so hopefully that kind of makes sense. So how is delta G calculated? Well, delta G, you can use the equation of delta G without the naught is equal to delta G with the naught, and that is at standard conditions, plus RT ln of Q. Q are at the conditions that you have right now, most likely not at standard conditions. So how do you calculate delta G naught? You can use your chart for one thing. All right, the chart at the beginning of your binder. You can use delta G naught equals delta H naught minus T delta S naught. All right, you have a couple ways to do that. All right, so then it says, what is the significance when delta G, not delta G naught, delta G is equal to 0? And guess what? You're at equilibrium. And then you start talking about K again. Okay, hopefully that helps. I'll see you shortly because you're going to watch the next one.